All right, so we're going to do a quick overview of sort of the main categories of series that are going to be on the AP test this year. So the first one is a geometric series, and so this is sort of the format. You've got some constant, and then you've got a multiplier, and that multiplier is raised to the power. And so the series variable is n, and that's in the power, and that's sort of key to remember. And so, you can have all sorts of series, but we could start with 8. And then the multiplier could be 1/2. And so we keep multiplying by a half. And so this is sort of geometric. And so that R is called the common ratio. It's the ratio between two consecutive terms. And so that's a nice way if they actually are listing the terms to see if it's geometric, just take a term, divide by the one that came before it. Do that a few times, make sure you're always getting the same thing. And that R value turns out to be the key one because that's going to determine if the series converges to a finite number or not. And the way it's often written is that R has to be less than 1 in absolute value, which is, of course, equivalent to saying that R is between 1 and -1. And so in my example here, R is definitely in that range, and so this is going to be a convergent series. If it wasn't in that range, then it would automatically diverge. You may remember geometric series are basically the only series in here in this class where we automatically sort of know what it converges to if it converges. I like to write it out like this, just using the words here, first term over 1 minus the multiplier, 1 minus r. Because sometimes they'll play some games with whether they start at 0 or 1 or 2 or what. If they put n equals 0 here, then r to the 0 is 1 and the first term is a. But sometimes, like I said, they mess around with that. In this case, the first term is 8 and the multiplier is 1/2. Whoops. And so we have 8 over 1/2. And so this series, not only do we know it converges, but it converges to 16. Next kind is a p-series. And a p-series, notice this time the indexing variable, the counting variable, is the base of an exponent. And so if p was 3, for example, we'd have 1 over 1 to the third plus 1 over 2 to the third. And so it's that base that is counting up. Zoom in a little bit here. And it's the power that stays the same. And so P you can sort of think of as standing for that power. It's sort of backwards from the geometric series. In the geometric series, we want the ratio to be sort of small. That makes the terms get smaller as we multiply and convergent. In this case, we actually want the power to be bigger because as the power gets bigger, the fractions get smaller and it makes it easy to converge. And so converges if the power is greater than 1, diverges less than or equal to 1, and it's important to remember where that bar is. It diverges when p is 1, and they give that special name to p equals 1, the harmonic series. And so that's just the sum of the reciprocals of all the integers, and that turns out to diverge. So that sum is going off to infinity. The next video will talk about the alternating series, and in particular we'll talk about the alternating harmonic series. That one's convergent, but the plain old harmonic series where p equals 1 is divergent. So these are sort of the main series that will show up this year, geometric and p-series. Make sure you can keep them straight and when each one converges.